So our goal today, we're doing arithmetic series. Here's the problem of the day. We have an auditorium, okay? We don't actually have an auditorium. It would be nice if we had one, but we're going to pretend we have one down the hall, okay? Cafetorium. Yeah, but a real auditorium, right? So we got to figure out how many seats are in this auditorium. So we know there's 20 seats in the first row. And then the next row, because they just add a seat to the ends, there's 22. And then the next row, there's going to be 24, and then there's 26. And then there's 28, and then there's 30, and so on and so on and so on. The pattern continues, right? And then we also know there are 200 rows in this auditorium. It's a big auditorium. My question to you, how many seats are in this auditorium? Anybody want to race? I'll tell you what, I'll race you. You guys have calculators in front of you? You tell me the correct answer before I can calculate the correct answer, and I will guarantee you get an A this year. It's done. You don't have to do it anymore. I don't know the answer. I just made this problem up. But I just made it up. I don't know the answer to this.
You have a degree in math.
I do.
It's not fair.
I do. You're right. It's totally not fair. But I'm also gambling that I can get the answer. You're already working on it before you. And I don't even have a calculator in front of me yet.
Okay, I got it. 4,000. 40,000.
4,000? 40,000? All right. So I would do...
I got it.
20.
800. 800.
4,000.
I got the wrong number.
Start at 20, add 2 to 200, 4,000.
I just got
It's 800.
2 times 10.
All right. I got the answer.
800?
It is not. Did you get the answer?
Definitely not.
What do you got?
4,000.
Eh.
I got 3.2
8,000.
times 10 to the
All right. Nobody wins the free A. I was going to give you an A for the semester, too.
100. 101. 102.
The correct answer...
200.
201. 202. 23. 435. 8. I was close.
Now, the question is, how did I do that so fast?
I'm going to go with a calculator.
Well, but what did I type in the calculator to get that so fast?
Formula.
Now, these are what are called arithmetic series. Okay? Now, why is it called an arithmetic series? That's the first question. Well, what type of pattern is this? We've done two so far, guys. We've done arithmetic sequences, and we've done geometric sequences. This would be an example of a... Why is it arithmetic? You're adding. You're adding 2, add 2, add 2. How did I get these numbers? I just went plus 2, plus 2, plus 2, plus 2, plus 2, right? Now, one way to solve this problem really would be 20 plus 22 plus 24 plus 26 plus 28 plus 30 plus blah, 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 all the way to the last term, which would be A sub 200. Agreed? Because what does the A sub 200 stand for again? The 200th term, right? And I'd have to add A sub 199 and so on, right? All those terms together. Yeah, one way would be to write them all out and then actually add them together. Would that be a very efficient way of doing this?
Definitely not.
That's definitely not what I did, right? So the question is, how did I do this? We'll come back to this. Arithmetic series, we denote, instead of A sub n, we denote it S sub n. Okay? S just means a series. And what's the only difference between an arithmetic sequence and an arithmetic series? In an arithmetic sequence, we're just looking for the terms. We're just saying, if I said, find A sub 200, what am I asking you to find? And in this problem, it would be how many seats are in the last row, right? How many are in the 200th row? If you're sitting in the back row, how many people are sitting with you, right? That's what A sub 200 stands for. S sub 200 is what we are looking for. which would be what? Add up the first 200 terms, right? So the only difference between an arithmetic sequence and an arithmetic series is in a series, we're not only finding the terms, we're also adding them together, okay? There is a shortcut approach to this, and it's actually quite simple. Now, the math behind why it works is kind of interesting, how they actually came up with this formula. Would you agree that this is a sub 1 plus a sub 2 plus a sub 3 plus a sub 4, blah, 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 all the way to the end, right? So it's a sub 1 plus, how did they come up with a sub 2? How do you get a sub 2? How did I get 22? I added the 2, right? So I took the a sub 1 and I added the d value, right? So this is my first term. That's my second term. What's my third term? It'd be a sub 1 plus,
D squared.
not d squared, but 2d's, right? And then a sub 1 plus 3d, and plus a sub 1 plus 4d, and 5d, and 6d, all the way. The last term would be a sub n, right? The term before that, you could think of as a sub 1 minus d, right? If you just subtract one of the 2's, right? And then you could also take a sub n minus 2d, right? And work your way back to the front. Agreed? Okay. Watch what happens when we write it slightly backwards. And we say, all right, let's put the last term first. So then the one next to that is a sub n minus d, right? We're going to work our way back forward. Plus a sub n minus 2d, and so on and so on and so on. The last term, what's the last term of this list going to be? A sub 1. And then again, we could work it, you could think a sub 1 plus d, that's the one, right? If we just write this backwards, a sub 1 plus 2d, and so on and so on. Now, think of it like system of equations here. Add these together. What happens when I add these together? What cancels out? The d's cancel out. 1d, negative d, 2d, negative 2d, negative 2, positive 2, negative 1d. All the d's go away. You get a sub 1 plus a sub n plus a sub 1 plus a sub n plus a sub 1 plus a sub n plus blah, 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 plus a sub 1 plus a sub n plus a sub 1 plus a sub n. And you have all of these a sub 1 plus a sub n's. How many pairs of these would I have?
100.
However many what? However many terms I would have, wouldn't I? I'd have n of them. Now, the problem is if I add this plus this, do I get s sub n plus s sub n as s sub n?
No.
I get what? I get 2 s sub n's. I'm not looking for a formula for twice the value that I want. I want a formula that gives me just s sub n, which would then all I have to do is, so I want you to, this is our formula. This is the formula that I used right here. This is your main formula that we're going to memorize to solve arithmetic series. But I want you to understand what it is. This is where it comes from. I want you to understand what these terms, dang it, I wrote that wrong. What all these terms just mean. What is n? The number of terms. In my problem that we're trying to solve here, in our little race for the auditorium, what was n?
200.
200. Because there was 200 rows, right? What's a sub 1 stand for? That's the first term, right? That's how many terms. So we're looking to solve S sub 200. That's the sum of the first 200 rows, right? So n is 200. My first row was 20. What's a sub n in this case? This is the last term. All I had to figure out was how many seats were in the last row. How do I find how many seats are in the last row? How do I find a sub 200? I have a formula for that. What was the arithmetic sequence formula for a sub n? It was a sub 1 plus d times n minus 1. All I had to figure out was, well, my first term was 20. I was adding 2 each time. If I want to find a sub 200, n minus 1 would be 199. So in my calculator, it's exactly what I did. I typed in 20 plus 2 times 199. What is the answer to this? 418? Now, all you have to do is go 20, because that's the first term, plus the last term, times 200 and divide by 2, or just times by 100. And what do you get as an answer? I'll bet you get this 43,800. You better get 43,800.
Yep.
Yeah. Now, here's another reason why this works. Here's how easy this is. Give me a starting value. Any starting value.
63.
63. Great. Let's add. Fine. So we're going to go 67 plus 71 plus 75 plus 79 plus 83. Tell me when to stop. Okay, 1, 2, 3, 4, 5, 6, 7. Let's do one more just for good measure. And we'll go 91. Okay? Watch how easy this is to add together. You could add those all together. You really could. Or you can do this. Add the first and the last. What's 163 plus 91? 154. Oops. 154. Okay? Add the next two terms together. Huh, weird. It's 154. Add the next two terms together. What do you get? Huh, it's 154. What do you add those together? What do you get? Oh my God, it's 154. How many 154s do I have? Why do I have 4 of them? Because it's half the number of terms.
What are you teaching us right now with that?
616.
Watch. Now look at the formula. I do the first term plus the last term. How many of those pairs am I going to have? I'm not going to have the number of terms that I have. I'm going to have half of those. That's all you have to do to add up an arithmetic sequence. First term, last term, add them together. Figure out how many of those would you have, and you'll always have exactly half of those. Now, what if, in this little example here, let's get rid of all the 154s, right? What if I said, all right, let's get rid of that 91. Let's just add those together. That's totally going to change this, right? I got an odd number now. I'm not going to have a pair. Add those together. What do you get? 150? That's nice. Add those together. Okay? Add those together. Uh-oh. I don't have a pair.
That's half of one.
But it's exactly half of the pair! So it's still, I add those together and I got 150. I now have 7 of those divided by 2.
All
I have 3, because there's 1, 2, 3, 4, 5, 6, 7 terms. I have 3.5 of those, right?
Yup.
Which is the same as timesing by 7 dividing by 2. So it still works.
Man, it's almost like
Okay.
I've done this before.
Almost like this works perfectly. I really am. Okay?
I'm confused. Like, what do you, I
You're
don't know.
just mathing. You gotta, that's fine. You know.
Do you see where I get the 150 from?
Yes.
Do you see where I get the 7 from? That's all you need to know.
Divide by 2 no matter what.
No matter by 2, no matter what. Okay. So, you might want to write these in your notes. For arithmetic series right now, for arithmetic patterns, we have our a sub n formula, which was a sub 1 plus d times n minus 1. What do we use that formula for?
A sub n.
But what are the a sub n's?
Finding the term.
Finding terms, right? If I'm looking for how many seats are in the 200th row, there's my formula, right? Now we have a formula for s sub n. And what is the difference? The s sub n's do what? Find the additional. You're adding up all the terms. We're not just trying to find the 200th term. We're trying to add up the first 200 numbers, right? What was that? And that formula is you find the first term, you find a sub n, or the last term, you times it by the number of terms, and just divide it by 2. Easy enough? Now, the weird thing is, look at those two formulas. We can actually take these two formulas and make a hybrid formula. We can combine these two formulas. What do you notice about this formula and this formula? More importantly, they both have a? They both have an a sub n, don't they? So what we can do, and this is a pretty semi-useful formula, we can take that s sub n equals n times a sub 1 plus a sub n. We can take this formula and we can replace this a sub n. And what could we replace that a sub n with? We can take this out, replace it with all of that, which would be a sub 1 plus d times n minus 1. And then we can just simplify that just a little bit, because we have n times a sub 1 plus a sub 1 would be 2 a sub 1s plus the d times n minus 1. Now, this formula here, I get it. It looks a little bit uglier. It's more math. But I want you to look at what you need. And I want you to think about the problem that I actually had to start the day. In order to solve this, but I want to show you how easy this is. With this formula, I needed to know the number of terms. I needed to know the first term. And I needed to know the last term, right? Do I need to know the last term to use this formula?
No.
I instead only need to know the d value. What I could have done is I could have said s sub 200 was 200 times 2 a sub 1s. What was my a sub 1? 20. Plus my d value, what was I adding each time? 2. Times n minus 1 would be 199 divided by 2. I don't need, and you'll get the same answer. I actually don't even need to calculate the last term if I don't want to. I can use this other formula. This other formula is for a specific type of question. That's kind of the question that I started with. it would only be useful if I needed to add up a bunch of numbers. Should be the same answer.
Crazy, man.
It's only going to be useful if I don't know the last term. If I know the first term and the last term and the number of terms, I'm using that formula every single time. I would say in your homework, you're using this formula 90% of the time. But every once in a while, instead of knowing the last term, I know the d value instead. Then this formula comes into play. Do you have to have that? No. You could have done this problem the same way I personally did it, which was instead of a one-step problem, I just did it in 2 steps. I thought, what is the last term going to be? That's easy enough to calculate. All I had to do was 20 plus 2 times 199. I did that. I found the last term. And then I took that answer and plugged it into the second formula. So I used 2 formulas instead of 1. Can you survive without ever learning this formula? Yes. It's just a shortcut formula. It's a hybrid formula. You take 2 and turn it into 1. You don't need it. It's helpful once in a while. These 2, you need. Does that make sense? And yeah, I'll admit, I didn't do that problem this way because I don't memorize that formula. I have these 2 memorized. Those are easy. And I knew the process because it is helpful to some people. Some people like the hybrid formulas. Some people like doing things in 1 step instead of 2 steps. That's what it's for. Okay? All right. There's one more thing I got to teach you. Something new. This is brand new. And this is going to scare some of you. Ready?
Scary.
Oh no, that's another Greek letter. Wait, why is there numbers on top of it and on the bottom?
What? Oh my God, that looks so scary. I'm out. I'm walking out. This is what is known as sigma notation. Why is it called sigma notation? Because that is a Greek letter, and guess what letter of the Greek alphabet that is? Sigma. Now, all you need to know, sigma means sum of. If you ever see sigma notation in math, it means add them up. This means, the way you would read this is the sum of the first term to the 8th term. I'll just write the number 8. First of all, where did I get the first and the 8th?
Well, I see a 1 and I see an 8.
Top and the bottom. This means start at the first term, end at the 8th term. We're adding all the numbers between there. This means add up a sub 1, a sub 2, 3, 4, 5, 6, 7. Stop when you get to 8. That's what those numbers are. That tells you what terms you're adding together. Of 2n minus 3. That's how you would read that. You'd see this and go, oh, so that's the sum of the first term to the 8th term of 2n minus 3. This is an arithmetic sequence. You're going to use the arithmetic formula. How many terms are there from 1 to 8?
9. 8.
Let's see. There's 1, 2, 3, 4, 5, 6, 7, and 8 of them.
There's 8.
If you don't believe me,
No, we just
a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, a sub 6, a sub 7, and a sub 8. 1, 2, 3, 4, 5, 6, 7, and 8 of them.
I believe.
Yeah, okay.
I only believe because you wrote it out.
Yeah. So there's 8 terms, right? Well, how do I get my a sub 1? You take a 1, you plug in a 1. 2 times 1 minus 3. Negative 1. How am I going to get a sub 8?
Plug in the 8.
You plug in the 8.
15.
15.
No, it's not. It's 13.
I was just seeing if you were actually doing real math.
You're kind of questionable sometimes yourself.
So all I have to do is find the first term and the last term, add those together, times by 8, divide by 2. So it'll be 12. What's 12? 72? So you got 12 times, no. This would be 48. Because that'd be 4 times 12 is 48. Yes? Done. Done. Now, the nice thing about sigma notation is now we can do stuff like this.
This man's not
He never stopped.
It keeps going.
What is it? How would I read this?
From 7 to
The
10.
sum of the
The
first
sum of the 7th term to the 10th term. I don't even have to start at the first term anymore. Now this one is a little bit trickier. Okay, Seth, here's what I'm going to count on you. How many terms are there from 7 to 10?
4.
There's 4. There's the 7th, the 8th, the 9th, and the 10th. Yes. You got to think of it like the post, like you're setting a fence and you got to, how many posts are you going to put to have like a 20-foot? So if you put posts every 10 feet and you want to go 30 feet, how many posts do you actually need? You need 4 posts, right? Because it's only 30 feet, but you need a first and a last, right? So it's kind of the same idea with that. If you need help, just use your fingers. Some of you may have to take off your shoes once in a while. Okay, so everybody agree? There are 4 terms here. How am I going to find the first term? Plug in a 7. What's 7 times 3? 21 plus 21? 42. And then, how am I going to find the last term? You plug in a 10. You get?
51.
So I would do 51 plus 42 is 93. 93 times 4 divided by 2.
That's like at least 30.
Okay? Good?
At least 10.
Pretty good with these?
186.
186?
At least 30.
Okay. Now, for a problem like this is starting to get to that borderline of this actually may have been easier to just find those 4 terms. Like plug in a 7, and yup, it'd be 42. And then you're basically adding 3. So it's 45, 48, and 51. Is there going to be times when it actually is just easier to do it the long way?
Yeah.
Probably.
Wait, so why is our answer 186 the base of
You have to add them all
You still got to add them together.
Oh. Yeah.
Yeah. All right, so everybody take a look at page 387.
This one's easier than the other one.
I agree.
Let's look at page 387. And I want to try the first problem of your homework today. Number 3 is sigma. What? No, not quite. So sigma from j equals 2
What the heck is that M?
to 4
Oh.
of what? J plus 3?
Is this our actual homework?
Yes.
This is the first problem.
This is the first problem.
3.
Okay. What is this saying?
387.
7. I mean, well, we're on 3.
It's the practice exercises, guys, not the classrooms.
That's just dumb that they
Oh, wait. Give me a second.
This is the sum of
2.
from the second term to the 4th term of j plus 3. Now, I would say this one might be better just to use the long way. Find a sub 2, a sub 3, and a sub 4, and then just add the 3 numbers together. Plug in a 2. What do you get? 5. I know. Try that again. You get a 5. Plug in a 3. What do you get?
6.
Plug in a 4. What do you get?
7.
Add those numbers together.
18.
That, to me, would be the easiest way to do that problem. Could you have also used the formula? Yes. There are 3 terms. The first term, you plug in a 2, you get a 5. You plug in a 4, you get a 7. You're going to get the same answer. Why is this one probably just easier to almost do it recursively, where we just write them all out and find all the terms and then add them together? There's only 3 of them.
And they're single digit.
And they're easy to find, right? So, and they're small numbers. There is a time and place where the long way is the better way. But, generally speaking, you know, like number 6. Are you going to want to do that one with a formula? Or? So that one's what? K equals 9 and 13? So 9 to 13 of what? 2k minus 3? Okay, so step 1, how many terms are there? 5 terms. Subtract them and add 1. That's how you always find it. Okay? And then, how are you going to find the first term? Plug in a 9. What do you get? So 15. And then, plug in a 13. Find the last term. 23. So add them up. Times by 5. Divide by 2. What is it? 95. Easy enough?
Yeah.
Okay. I told you, guys, these look scary, but they're not necessarily scary. Now, when you get to 9, 10, 11, 12, that grouping, you're using one of the 2 formulas. You're either using this formula or that formula. That formula. How will you decide? Do you know the last term? Or do you know the D value? Like number 9. They give you the first term, they give you the last term. I'd use that formula. But for number 15, they give you the first term and they give you the D value. What should you use? I'd use that one. Use the hybrid formula. Make sense? All right. Now, I want you guys to look at number 25. What's number 25 say? 3 plus 7 plus 11 plus 15 plus blah, 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 blah. They want us to write the sigma notation for that. What do they tell us to write the sigma notation for? For the first 6 terms. What are the first 6 numbers? Where do they start? They start at 1, and they end at 6. Oh, mind-blowing stuff. Now, this, what goes here, is the formula that would spit out a 3, a 7, an 11, a 15. That is known as your general term. That equation that we use to find all the terms. That's our a sub n equation. Our a sub n equals a sub 1 plus d n minus 1, right? What's my a sub 1? 3. What's my d value? 4. And I don't want an n value because I want to be able to plug in a 1, a 2, a 3, a 4, right? Now, if you just put that in there, you're correct. But again, I have higher expectations. You should be able to simplify that just a hair, which would be what? 3 plus 4n minus 4, which would be 4n minus 1. This would be the answer to number 25. Does that make sense? Where did I get the 1 and the 6? From the directions. It said write the sigma notation for the first 6 terms. If they said the first 8 terms, that'd be an 8. And then this is always going to be your general term. What is that formula you use to find all the individual terms? Does that make sense? It's actually a lot easier to write than you think.